So before we begin, I've added some nonsense in our group chats, just because I think it's going to be super, super duper helpful. So this is essentially, and I'll zoom in, don't you worry. This is essentially what I believe should be a pretty good timeline for you to follow, a pretty good guideline to follow when you are studying for your exam. And as you can see, if I zoom in just a little bit, we're obviously today, we're Wednesday, this is exactly where we're at. And we're going to be doing some capital budgeting in WACC. So that's probably what you should study on. And then I gave you essentially on this little table here, a bunch of different things that you should kind of maybe look at based on what day you're in your studying process. So just to make it clear, there's about what, I guess, 8 things that you could be doing on on a day-to-day basis. You can be either joining the tutorials, you could be, looking at the deliverables that we have in our tutorials, you could be looking at the notes, the lecture slides, practice problems, YouTube videos, recordings, and all that stuff. So the idea here is that what I wanted to give you is kind of just a really good benchmark to figure out, well, what should I focus on today? What should I not focus on today? And kind of like if you have the time, you just do everything. So I think this is helpful. This is how I went about studying. I really focused on, these different buckets. I looked at them every day. We have 8 days till the final. And in here, you also see where to find these different resources, okay? You also get to see, for example, you get to see what are my recommendations based on these different resources. And just to give you a quick, 2 cents here, I think that up until perhaps, Saturday, you should be just doing the final steps for capital budgeting, cash flow estimation, and then also a little bit of a recall on TVM and bonds. Then after that, I think it's a big, big, big focus, okay, on doing mock exams every single day, not only with me, but also on your own time. And what I mean by that is by taking the time to, for example, having some papers with you, acting like you were taking an exam, timing yourself, and not having, YouTube or Chegg or even Spotify on, nothing. Just do the questions and ideally have a cheat sheet or a formula sheet with you and do every single one of them. And it's fine if it's not great, and it's fine if it's amazing. You just want to be able to put yourself in that kind of setup. I think that's an entirely huge game changer. That alongside the sessions that we're going to do together, that alongside the different things that you could do on a day-to-day basis, I think is an amazing tool to success. Like at the end, and I'm talking a lot, I'm sorry, but at the end of like this whole like journey that we're going through, at the end, you could literally say, well, I did this, for example, I did these notes, I did this, and if you accomplish every single one of them, or at least accomplish the highs, the very highs and the mediums, I promise you, you're going to do so much better than what you have had in the midterm, and you're going to surprise yourself. So that's kind of like my spiel on something that could really help you move forward. Just for the last steps here, our session will probably be up until 8 p.m. The notes, the deliverable for today, I'll put it in the chat again. Okay, the deliverable for today is a document that we're going to use to kind of do the questions that we need to do. I'm putting it in the chat again, but it's also in our Google folder. Okay, so this is Com 308 final practice problems. That's a document. It's in our Zoom chat. It's also in our Google folder. And then if you have time, review the notes, before going to bed, the final notes. Then if you have time, read up again on the capital budgeting slides. There's 2 of them, read through them. And then try to do 5 questions at least from this document that we did not cover today. All right. Then you could also look at the advanced crossover rate video that I have here and a past recording. I think that if you do every single one of these and you actually take notes, yeah, for sure, George, I got you right after the session. You'll have it, no problem. And if you do that, you'll be fine. Obviously, if it's with red, like it's written low, I probably don't recommend forcing yourself to do it at first. I would recommend doing it once you finish the mediums and the highs, right, that are really important, and do them in, their full breath. So you want to go hard at it. anyways, that's it. In terms of like the studying guide, do you have any questions, any insights, any recommendations, or no? How do y'all feel? I think it's fine. Okay, seems like we're good. Okay, so that said, let's look at some questions. Let's look at some questions. So what we're going to do is we're going to open this doc, you know, the chapter final practice problems document. Okay, we're going to open that doc and we're going to go all the way to the end of this document. So all the way to the end of this document, that's where we're going to find the chapters on capital budgeting and all the good stuff. Okay, so you have to go all the way to the end, past market efficiency, past all that jazz, such that we get to the capital budgeting question. All right, and I'm gonna highlight the ones that I would really like to do. So just give me a sec. We're gonna find that in a second. I'm kind of gonna try to focus in on a few that I especially care about. And if they're not in this document, we're gonna move on to another one. Just give me a second. Let's go with this. Okay, we're gonna start with this one first, and I guess we're gonna hide. Let's see. Yeah, we're gonna jump straight into questions. Oh, you can just see the Excel. Hey man, that's probably true. That's hilarious. My bad. Now you can see everything. I'm so sorry. I'm so sorry. So now you can see everything. My bad about that. But I really want to begin with this idea of IRR. I want to start with the complicated questions because we don't have as much time, you know. So we'll go with that. So IRR, and that's an important topic. IRR is part of the different measures that we may have when we're doing our capital budgeting type of questions. It's something that you see often. And just for fun, can somebody tell me in the chat, what is IRR? What is IRR? What does it stand for? The IRR. What does that stand for? Can somebody in the chat tell me, what does IRR stand for? What is the literal, like, this is that, it's like an acronym? Like, what does it stand for? Somebody tell me in the chat, what does IRR stand for? Okay, I have one answer. Do we agree with Palanver? Is that fair? Do we agree with him? Does that stand for IRR? Yeah, 100%. So the IRR is the internal rate of return. Okay, and essentially, the IRR is a very specific and a very important little subset of our idea of an interest rate, our idea of a K. It's a very specific discount rate. It's a very specific interest rate. That's what the IRR is. It's a very specific one, which holds a lot of meaning, okay? And just to make it simple, and I'll actually run a little example, all right? Let's say we wanted to find the present value, okay, of, let's call it $5 million you're going to receive in 10 years, okay? $5 million that you're going to receive in 10 years. And we're telling you that, okay, the interest rate, so you could call this the K if you want, is equal to 6%. Could somebody tell me what would be the present value? I actually will want all of you to solve for that. If we know the future value, okay, we have money that is $5 million in 10 years, okay? We want to know what's its value today. So if I want to draw it to T0, T10, you have 5 million. You know that K is equal to 6%. I want to have the present value, okay? I need everybody to find this answer. It takes 2 seconds, and then you'll see why I'm taking the time to go with that. And it's going to serve as a very good propeller to our problem here. Okay, so can somebody please tell me what is the present value in this scenario? Okay, what is the present value? Put it in the chat. What is the present value? What is the present value? It's a very easy question. It should take 2 seconds. I'm gonna give you all. Okay, so Bashir says one answer. I need like 2 or 3 more people. Okay, perfect. Okay, good. Just to make it super clear, to find the present value, you could either use your calculator or you could just simply do this. So 5 million, right? Over 1 plus 0.06 to the power of 10. Now, obviously, that's a super ugly way of writing it. But if I want to write it in my calculator here, I could just do 5 million divided by 1 over 10. I mean, 1 over 6, sorry, to the power 10. And I guess I am slightly dyslexic. No, I'm not. Okay. So yeah, this would be your present value. All right. So obviously, your present value is bigger than 0. I think we could all agree that your present value is bigger than 0. Yeah. I think that's fair for everybody here. I think we could all agree that our present value is 0, 100%. Now I'm actually going to stop being funny and I'm going to give you a concrete example of what this idea of the internal rate of return is and why it matters so much. So let's double down on the example that we just gave. So we're going to look at a range of interest rates. Okay. In this case, we started with 1%, I mean 0.6%, but let's begin with actually 1%, for example. Okay. We're going to have 1% and we're going to look at 2% and we're going to progress for a few percentages just to be cute. Okay. So actually, you could even go further than that. I guess I'll do 0%. So you'll see exactly what I'm trying to do. All right. And then we'll put it at 6%. Cool. All right. And then we're going to look at our present value. Okay, so we're still looking at and we're still seeking the present value of $5 million. Now, all of you could, of course, agree that $5 million, all that we had to do was essentially have this. So give me a sec. Okay, so this is our present value at 6%. All right, now bear with me. It's all going to make sense in just a second. So this is our present value at 6%, and it makes sense. We're all happy with that. Okay. What's also interesting, though, is that if I asked you, and I won't because I don't want it to be the focus, but if I asked you, I could say, hey, well, what would be the present value at 5%? Okay. We notice that it now becomes 3 million. What would be the present value at, call it 4%? It would be 3.7 million. I mean, 3.3 million, sorry. And then at 3%, 3.7. Then at 2%, it would be 4 million. And then at 1%, it would be 4.5, okay? That would be the present value at 1%. Let me ask you a quick question. Is our present value increasing as our interest rates are decreasing? I just need a quick yes or a quick no in the chat. Bashir says yeah. Pamvir says yes. What about Georgia? What about Lean? Are we seeing what I'm trying to display? It's a very simple idea. And this is actually something that could be in multiple choices. But what I want to do right now is just focus once again on the underlying ideas at play when we're looking at the relationship of present value to interest rates. Okay. Now, by definition, technically, although impossible to be below, 0, I'm not going to go to -1 or 2%, but the idea here is that obviously, if we have 0% as our discount rate, we would have a present value of $5 million because simply, just to make it super clear, because this could be a question on an exam, 5 million divided by 1 plus 0, okay, is simply 5 million because you're just dividing by 1, okay? So that's why this right here is giving you 0, just making that super clear, all right? But this is important. So we understand that the smaller our discount rate, the higher our present value. That's super, super duper cool. Okay. But what's the smallest potential value, okay, for this specific investment or for this specific scenario? Or in even other words, is there a point where our present value is less than 0? Or is there a point where our present value is $0? This is very, very, very important. And we could try to seek that point. We could try to figure it out together. Oh, sorry about that. We could try to figure out that point together. And this is going to be essentially a very cool way for us to find it. So we're going to look at 10%, we're going to look at 20%, we're going to look at 30%, we're going to look at 40%, we're going to look at 50%. Don't forget that this is your K, all right? So as you can see, the more we go up, the smaller our present value. So once again, another statement that I like to say, the higher our discount rate, the higher our interest rate, the smaller our present value. Is that something that we're all seeing right now? Yes or no? Quick yes, quick no in the chat, just to see that we're on the same page. Okay, cool. It's gonna be my last, my last example. But then let's continue for two other sets. Let's go at 75% and let's go at 90%. What would happen to our present value? Okay, well, it's getting smaller and smaller and smaller. Very, very, very interesting. Okay, so the more you go, the smaller your present value. Okay, and the IRR essentially, all right, is a specific discount rate at which your present value is going to be equal to 0. Now you may be asking yourself, well, in this case, if I went to like 100, in this case, it seems that our discount rate is actually never going to get to 0, okay, because it's converging to a point, which is totally fair. But the idea is that in real life, you're not just looking at one amount. In real life, you're looking at what we call cash flows. We're looking at cash flows, okay? So we're looking at how much money can a project or a company or a stock create for you versus the money you had to invest today. And that's where this whole idea of IRR comes into play, because we're going to try to assess to what extent is the money we're investing today beating the future cash flows we're going to receive in the future. Okay, so now the last step that I'm going to do before we move on to a question is just give you that example. All right, I'm going to visualize it. So it's going to be the same example. Okay, we're going to have t equals 10. All right, like before, and we're going to have $5 million that we're going to receive in 10 years. Okay, remember that K is going to be, well, we don't care about our K actually. Okay, so we're going to receive $5 million in 5 years. All right, but that's because we essentially gave our money today. All right, at t equals 0, we decided to invest, call it $3 million today. Okay, so we invested $3 million today to expect to receive $5 million in the future. All right, we received $5 million today to essentially receive $5 million in the future. All right, that's super duper important. Now, that said, let me play a little game with y'all, okay? With all the information that we have here, okay, there's no wrong answer. Could you tell me a point at which our present value is going to be smaller than the initial investment we made? Okay, can you tell me when that begins? When is our present value going to be smaller? Okay, so when will the present value be smaller than $3 million? Can you tell me when that begins? In this little table that we built, when will our present value be smaller than 3 million? Okay, Paramvir says 5%. Bichir says at 6. These are both amazing answers. Totally fair. Lean says at 6. Okay, perfect. Technically, this is an amazing question. So, I mean, a bunch of amazing answers. So technically, we could say that our net earnings, we could say our net profit or our net losses in this case, okay, our net profit or losses technically could be simply written as this minus 3 million. And then as Bichir and all of y'all said, clearly we start losing money around 5% to 100%. We start having an investment that doesn't seem to make sense between 5 and 6%. Our present value will actually be smaller than the money we had to spend today. Now, would you be happy if the present value of the money you're going to receive in the future is smaller than the investment you had to make today? Yes or no? Would you be happy with that? Would that be a problem? Yes or no? Tell me, would that be a problem? Would that be a problem if your present value is smaller than the investment you made today? So you invested $3 million and I'm telling you that your present value is going to be smaller than that. Are you happy? Are you smiling? Or are you upset? We're sad, right? We're very sad. That's a problem. Okay. So that's super interesting. There's a point, right? There seems to be a percentage at which we start to lose money. Seems to be a point at which this is no longer a profitable project. Okay. There seems to be a point at which this is no longer a profitable investment or a profitable project. Very interesting. But what if we want to find the point at which our present value is exactly equal to $3 million? What if we want to find the point at which right here, I put this, sorry about that, that right here, we would have $0, where present value would be equal to our $3 million. How do we do that? How the heck do we do that? Well, what you could do is actually you could solve for the IRR. And the IRR is that exact point. It's the exact point where your present value is equal to your original investment. In this case, is the exact point at which our present value is equal to $3 million. In other words, you would be making $0 of profit and $0 in terms of losses. That's an amazing, amazing thing to understand. So in other words, how you would do this is simply as follows. You would do 0 is equal to, right? 0 would be your present value. Okay, this would be your present value is equal to 5 million divided by that specific rate that we're looking for, that specific K to the power of 10. And that's going to give you this IRR that we keep on talking about, because the IRR is the point at which your present value, okay, is equal to your original investment. You could call it CF0, or you could just call it here your initial investment. Okay, that's what the IRR seeks to do. The IRR is that specific point at which you are indifferent. It's a specific point at which you don't care. It's a specific point at which present value is equal to the initial investment. All right, super important. So now my last little brain teaser before we move on to actual problem solving that's on the exam. Let me just ask you this. What is our K? What is our IRR in this case? You just got to solve for X. I need some people to tell me what is our K. What is our IRR? What part do you want to repeat? Like about the IRR, about the... Yeah, no problem, no problem. So let's go with the example. Let's go with kind of just following what we just did. So let's look at time, right? We're gonna have year 1, or just actually today. We're gonna make it interactive. So we have our time here. We're gonna go all the way to year 10, okay? And we have today. So this is gonna be cash flows, discount, yeah. Okay. So I think we could all agree that in this specific example that I gave out, we're spending $3 million, whoops, today. I think we could all agree that we're spending $3 million today. Is that clear to everybody? That we're spending $3 million today? Yeah. Okay, cool. We want to find the point at which our $3 million today, okay, would be essentially equal to the present value of our future cash flows. In this case, we're making $0 on year 1, $0 on year 2, $0 on year 3, $0 on year 4, $0 on year 5, and so on, all the way to year 10, when we're going to be receiving $5 million. That's exactly what my example is trying to denote. Okay, that's exactly what my example is trying to denote. Now, what we want to figure out is as I said before, the point at which the $3 million we invested, right, would be equal to the present value of this that we get in 10 years. Now, if you remember, you guys all said that it would be between 5 and 6%, okay? Right? Because if we do the present value of $5 million with all these different discount rates, we get a bunch of different values. We said that the smaller our discount rate, the higher our present value, and the bigger our discount rate, the smaller the present value. This has to be extremely clear. So now I'm asking you, what is the point at which our present value is exactly equal to $3 million? Okay, that's going to be the point at which we make no money on this investment. We make no money on this project. We are indifferent. I want to find that specific point. So could somebody solve this little equation here? 0 is equal to 5 million over 1 plus k to the power of 10. Minus 1%. In other words, actually, I think I'll make it clearer for you. I think this is a better way to say it. Okay. I think, sorry, I'll give it in a better way. Sorry about that. When is this equal to $3 million? I think that's a clearer way of saying it. When is this equal to $3 million? Okay, give me that instead. Sorry about that. Give me that instead. So Paramville says 5.24. I need a few people to give it a shot. When is this equal to $3 million? When is this equation equal to $3 million? Vale says 5.24. I need people to give it a shot. So 3 million is equal to 5 million over 1 plus k to the power of 10. What would be our k in that case? It has to be between 5 and 6. Vale says 5.24. I need everybody to give it a shot. I want you to solve this right here. Then I'm going to summarize what we just did, just to make it super clear. 5.24. I need one more person to give it a shot. One more person to give it a shot. $3 million is equal to 5 million. There you go. Exactly. As you can see, the answer is 5.24. Now, apologies for it being kind of all over the place, but I think we need to summarize this in a few ways. What we found right here is the point at which this specific future cash flow of $5 million at year 10 will be equal to $3 million. Is that clear to everybody? Yes or no? Just say yes or no. We found the point at which our present value is equal to the money we invested today. So 3 million is equal to $3 million. So in this case, if you are investing $3 million today, all right, and you know that you're going to receive $5 million in the future, okay? You know that you're going to be receiving $5 million in the future. The point here, this little specific point that we're looking at, the internal rate of return, is showing us exactly at which the present value is going to be equal to our original investment today. And now this leads us to a future like point that I'd like to make. If our interest rate, if our K was 6%, is our present value bigger or smaller than our original investment today of 3 million? If our K was 6%, is this amount bigger or smaller than this amount? Quick yes or no in the chat. It's smaller, okay? So in other words, our present value is now smaller than the money we've invested today, okay? If our interest rate, okay, our K was 4%. If the discount rate we used was 4%, is our present value bigger or smaller than the investment we made today? Can somebody tell me in the chat? Is it bigger or smaller than $3 million? It's bigger, okay? So if it's bigger, are you happy if it's bigger, are you happy about your investment? Because now you have $3.3 million. Essentially, your investment that you made today should be worth effectively 3.3, but you only had to pay 3 million, okay? But if your investment, its present value is only, call it $362,000 because interest rates are at 30%, are you happy or are you upset? One last time, just for fun. Are you happy or are you upset if your present value is 362K? Are you happy or are you upset? If you're in an original investment, exactly, you're upset, okay? And now, this is one way for us to tie it in a simple statement. Your internal rate of return, your K, is showing you the point at which you're actually indifferent or not. Another way to talk about your K would be to call it your opportunity cost, okay? Your K will represent the point at which, the interest rate on the market at which you would not care to be invested in a different project, okay? Let me tell you this. If we're promising you $5 million in 10 years, and you're investing $3 million today, but the rates are at 5.24, if you literally did the math, if you did this, okay? If you did this right here, if you did 3 million times 1 plus 0.524 to the power of 10, you would get $5 million. This is what it's telling you. It's telling you that, hey, this is the interest rate where you don't care about going into different projects, all right? But at 30%, okay, let's use this drastic example. If, the IRR was, or if your K was 30%, okay, if the interest rates were 30%, you would not be happy with this investment because it's only giving you an IRR of 5.24%. This means that anything above your IRR, okay, you would be unhappy with this investment, all right? However, anything below your IRR, you would be happy with your investment. So what the IRR is telling you, it's really highlighting the point at which this investment would make sense, where this investment would be okay for you. So it's a very good comparative tool. I think that's what's important here, because I'm sure all of you had questions. Well, can we just kind of like play around with the K? Can we just choose what interest rate we're going to use? Unfortunately, that's not how it works. The IRR is an amazing tool to be used for a specific project in a silo. You evaluate what would be the point of indifference for a specific investment or for a specific project. And that's going to give you a rate. That's going to give you your IRR. Then you're going to compare that rate towards what you could get in real life. The average interest rate on the market index, the average interest rate in real estate, the average interest rate, in your bank account, and et cetera, et cetera. That's what the IRR really hopes to do. So yeah, what's up?
So anything below the IRR is a loss and anything above is a gain, or we shouldn't see it like that?
The other way around. So anything below
above IRR is a loss, anything below IRR is a gain.
Yeah, it's like you're happy with that project.
Okay, thanks.
So let me just give you a final wrap up, because you're going to have theory questions. It's very possible. So in this case, we know that our IRR was 5.24%. Okay, this was our IRR. And let's say that the S&P 500, or just a market portfolio, or like hedge funds or an ETF, was only giving you 2%. Okay, would you rather invest in your project that gave you 5.24%, or would you rather invest in the market portfolio? Which one would you rather? Which one would you rather invest your money in? I need everybody to write it in the chat. Which one would you rather invest your money in? Bashir says the project. This is the project. Palanvir says the project. What about Lean in Georgia? What do y'all think? Let's think about it. The IRR, the interest rate that you could get from your project is 5.24%. That's your point of indifference. And the S&P 500 is giving you 2%. Which one is giving you the bigger percentage? Which one? Lean, what do you think? Which one is giving you the most interest? Exactly, the IRR, the project. So in this case, what's really cool is that because your IRR, right, is this indifference point, anything below your IRR, right, so 4%, 3%, 2%, 1%, would be considered a bad project to take instead. You would want to just invest into your project because your project is giving you, good returns, whereas anything else below that is not going to give you comparative returns. I think that makes sense. So let's look at a different example. Yes. The higher the IRR, the better. Because then this is amazing. Because then this means that it would take a lot for other projects to beat this specific investment you're making. It would take a lot for other investments to beat the project. So the higher the IRR, the more it takes for different projects to come to the same, standard. Let me give you another example. So now let's look at it, this example in blue. So your IRR for the project is 5.24%. Okay, it's 5.24%. Whereas this real estate investment is going to give you 25%. All right. Which one would you rather? Which one would you rather? Your project or the real estate? Exactly. You would rather the real estate investment because it's giving you a way bigger percentage, right? 25% is way better than 5.24%. So this 5.24%, as I said right before, anything above 5.24%, we would rather take over this project. And anything below our percent of 5.24, we would rather keep the project. So this goes back to my initial point, this idea that this concept of the IRR is an amazing comparative tool because you evaluate a project, you evaluate an investment, and then you compare it to other things out there that are available. That's how you figure out whether you make an investment or not. That's what the internal rate of return is all about. All right, it's a very important concept to understand. Okay, so with that said, now I think we have the tools. All right.
Just a small question.
Yeah, what's up?
So when you asked to compute the K in this question, like this is like an example. So we can't use TVM functions to like compute the K, right? Because it's giving me error.
Yeah. So like you did 3 million is equal to 5 million over 1 plus K to the power of 10.
Yeah, like I put the present value, I think 3 million, which is today.
Oh, for sure you can. Yeah, you can. Just do minus 3 million.
Okay.
Just do minus 3 million.
Oh yeah, because it's investment. Okay. My bad. Okay. Got
Exactly. Do that and you're totally fine.
Yeah.
So me, I'm a big fan, by the way. I know this is like blah, 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 but I'm a big fan of understanding because no matter what, if we go back to our timeline, we're going to do 3 crash courses that do this, for 2-3 hours when it's just doing questions. I don't want to spend time talking about theory then. That's not crucial. And then you have another set of mock exams to do. So you're going to have that exposure to, the classic, how do I solve a problem? Right now, it's really reinforcing the cues because when you took the midterm, a lot of people were like, I've never seen these questions before. And you're not going to see the same questions on the final. You could do 1,000 questions now, you won't see the same on the final. You will only be equipped if you understand the material. You want to have the different parameters set such that you know the material and you know how to use it to your advantage and you know the logic to be able to answer that question. Okay. So this next question that we're going to do together. So I guess I'll go down like this. This question that we're going to do together right here, which is about computing the crossover rate, is a very interesting question. It's going to mix 2 things that we need to understand. It's going to mix the concept of this idea of the IRR, and it's also going to mix the concept of the idea of the classic whatchamacallit, NPV. And you're going to see why I'm talking about this. You're going to see how we can make this, really simple and kind of easier for us. So that's going to be very fun. All right. So let's give it a shot. Let me just make sure I remember how to do it. Okay. So it's on our left. I guess I could zoom in a little bit if you want. Okay. So we have Nike has the following cash flows for 2 mutually exclusive projects, and that's a whole different conversation. Okay. And as you can see here, you have project A, you have project B. Okay. You have also estimated that the IRR of project A is 15.86%, whereas the IRR of project B, all right, is 14.1%. They're also telling you that the payback period is 2 years. All right. While the payback period for B is 3.2. So A is 2 years, B is 3.2. Okay. When is project B more lucrative than project A? All right. That is, over what range of discount rates does project A have a higher NPV than project B? When does project B have a higher NPV than project A? So right off the bat, if we want to highlight some key topics from this chapter that are being brought up in this question, you have the IRR, you have the payback period. Then you also have what we call is the NPV. You have these topics that are being discussed in this question. So already there, you already kind of have an idea of where we should be situated, okay? But before I begin, just quick question. Has anybody here seen a question similar to this? Have you ever had experience with something like this? Yes or no? It's quick yes or no in the chat. Okay. So what I'd like to say is that I've seen this on my exam. I've seen this on last semester's exam. I've seen it in another year's exam. Like, this is a classic question. I would definitely, oh, that's crazy. Nice. But the idea is that this is something you often see. And if not in this specific manner, you will need to talk about this idea of the crossover rate, either in a theory question or in a question just like this. Okay. So this is interesting. And I'm going to use graphs, and I'm also going to use just like tables written by hand. So I guess I could zoom in a little bit. All right. So technically, if we want to be kind of funny about it, we could essentially do this. We could write year 0, year 1, and you're going to see why I'm doing this, so forth, all the way to year 4. All right. Then you could put this as being, I guess, cash flows. Project A. Yeah. Yes. Okay. So we have our years. We have these 2 projects. Okay. That's exact. I'm just trying to talk about what you're seeing on the screen. What you're seeing on the screen is that you have 2 projects here with different cash flows and different initial investments. All right. And one last thing that I'd like to say is that the question is asking you something very important, and this should guide you in how you solve this question. The question is telling you, hey, over what range of discount rates does project B have a higher NPV than project A? Already there, it should be extremely clear to you that you're probably only going to look at these 2 topics, because they're only talking about the NPV in your question, and they're only talking about the IRR, i.e. the discount rate, i.e. the interest rates in this question. So I would probably want to focus on these 2, okay? It's very, very important. So just to be super OCD, I'm gonna kind of write down what's in the question. So we have 60K, we have 40K, we have 20K, okay. Then you have 30K, you have 40K, you have 20K, and 50. So by definition, you seem to have different cash flows. Obviously, year 1 has more, project A in year 1 has more cash flows than year B, than project B. They're the same on year 2, they're the same on year 3. But on year 4, project A has bigger cash flows than, project B. So we clearly see that, there are moments at which their cash flows aren't exactly the same, although there are some years where they are the same, and they also do have, an initial investment. Okay. And what's really cool is that they took the time to tell you, by the way, the IRR for A is going to be, call it this amount, and the IRR for B would be, call it this amount. So we could put them as percentages. Okay. Whoops. Okay, so that's pretty important. Now, what you want to figure out, because of this question, they want to know where along this IRR line, along this line of interest rates, is project B having a bigger NPV than project A. All right. So if you would want to have a pretty good visualization of this, and trust me, this will all make sense. I'm just throwing at you all the information you could possibly go through, is that they're asking you along the line of K's, right? You would have, for example, project A's IRR right here, and you'd have project B's IRR right here. They want to know, right? When is project B's NPV bigger than, call it, project A? So they would say perhaps here, right? Project B has a bigger NPV than project A. Anyways, all that to be said. What's really interesting is that we could try to plot this relationship on a interest rate to NPV diagram, a NPV to IRR graph. So you could do this. Okay, you could do this right here. So you could plot your K's right here, and you could plot your NPV right here. Okay, because this would give us the best way to be able to highlight the points at which our NPV is going to be bigger for what type of project and over what interest rates. All right, it's super duper important. Okay, so in the question, do they give us 2 specific IRRs? In this question, do they give us 2 specific IRRs? Quickly, yes or no in the chat. Let's assume that this is 0%. Do they give us IRRs in the question? Yeah, they totally do. They give us, the one for A and the one for B. So let's assume that right here we have A, which is going to be 15.86% for project A. And then we could put right here project B at 14.1%. All right, 14.1%. Okay, so we have 2 lines. All right, but we want to find the crossover rate. We want to find the points at which they intersect. Okay, and we want to find the points at which they're touching this graph. Now, what I'd like to do for fun is I'd like to ask you a very simple, very, 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 very simple question. Okay, and I guess the best way to do it, let me see if I have a very good way of doing it. Just give me a second. I'm trying to think about something. Okay, so let's do a little test for y'all. Okay, we want to know when is B bigger than A exactly. So let me run a test for y'all. Can somebody tell me in the chat what would be, all right, what would be our NPV, okay, if our K was 0 for both project A and project B? So can somebody tell me what would be our NPV? All right, what would be our NPV if project A and project B had a K of 0? Can you guys try to do that? And do you know how to do that? Do you know how to do that? Do you know how to find an NPV? All right, then no problem. I'll show you how to find NPV. So NPV is simply going to be like this. So you're going to do CF0, all right, plus the cash flows, the sum of the cash flows, all right, divided by 1 plus K to the power of N. Okay, so what does this mean? if we do project A together, what would be our CF0? What would be our initial investment? Could somebody tell me what would be our initial investment? What would be our initial investment for project C? Exactly. It would be minus $100,000. All right. Then we would do that plus 60K over 1 plus a K of 0, okay, to the power of 1. Then we're going to do the same thing for 40K. Wait, what's up? What's up? Why is 0? Okay, well, the reason why is 0 is because what we're doing is I want to find the points along this line. I'm just asking you a question. I want to find the points along this lines because if I could find a point for A, I could maybe, just maybe, do something like this, right? And just maybe these points, for example, would intersect. And then I'd be able to find exactly where project A or project B has a bigger NPV than the other. All right. So that's why I'm doing that. Just because I'm a visual person, I don't want this to be hard. And trust me, we're going to do this step by step, and you're going to understand every single step of all this. So that said, let's just finish up project A, and then I'll ask you to do project B. It'll take 2 seconds. So we could do 20K over 1.0 to the power of 3, and then 10K over 1 plus 0 to the power of 4. So could somebody tell me what would be our NPV in this case? It's a very funny answer. What would be our NPV in this case? It's a very funny answer. It's hilarious. Somebody tell me what would be our NPV given those numbers? Just one person could give it to me. That's more than enough, by the way. Just one person, that's more than enough. It's 70K. Is it 70K? I think you're slightly off. You could be slightly off. I could be wrong. Let me try again. Yeah, I could be wrong though. Yeah, you're slightly off. Very off. But close, but very off. The NPV. So remember, we're just adding these numbers up together. Okay? We're adding this plus this plus this plus this plus this. Don't forget that this is minus 100,000. Okay? Oh yeah, no calculator. Just like by hand, like what we're doing now. This is our cash flows. I want you to add these up, okay? Because of the formula here. All right. It's a very, there you go. There you go. So the answer is 30,000. Let me give you a quick little example. This is a quick trick on the exam, so you don't have to waste your time. So 60,000, right? Over 1.0 to the power of 1 will simply give you 60,000. And if you do the same trick for 40,000, you notice that 1 plus 0 to the power of 2 is still 1. So you get 40,000. But if you do that for the next one, 20,000 over 1 to the, like literally 1 to the power of 3 is still 20,000. So what's really interesting is that the lines along your vertical axis, all you have to do is sum all of these numbers up together, right? You don't even need to use this formula. You don't care. All you got to do, because you know that something divided by 1 will remain the same amount, right? You just got to add them up in your head, and it's going to give you 30. Okay. So is that clear for everybody that we don't even need to discount them because they're discounted at the rate of 0? Is that clear to everybody? Yes or no? Okay, exactly. So our NPV in this case is equal to 30K. So then can somebody tell me what is the NPV for B? What is the NPV for B? What is the NPV for B with a discount rate of 0? If our K was set to be 0, what would be our NPV? There you go. 70, yeah, that should be good. 70, 90, yep, 40K. all you have to do is do minus 100K plus 30K plus 40K plus 20 plus 50. Okay, that's amazing. So now what we could do is we could perhaps put this as being for B. We could put this as being for A, right? This is going to be 30K. And this will be for 40K. So you could literally just do something like this, right? And then you could do something like this. Okay. So now let me ask y'all a very easy question. Which project seems to be bigger between, like, let's say this is a point, we're gonna call this point X. Which project is bigger from 0 all the way to X? Which project seems to be having a bigger NPV from 0% all the way to X%? Which one, B or A? I need everybody to give it a shot. Lean says B, Bashir says B, Parmvir says B. Georgia, what do you think? What do you think? What do you think, Georgia? Is it B? There you go. Exactly. Now, this is very important, very, very, very important. As you can see, right here, any point that you take for B, call this B1, and this A1, no matter what, B will be bigger. Right here, you could take B2. And here you could take A2. B will be bigger. However, if we go here, for example, any point beyond this X point, we're going to see clearly that A, right, A1 is going to be bigger than, for example, B1, and so forth. So this is very important. We know clearly that any point before this random little intersection, project B will be higher. It will give you a higher NPV than project A. And any point beyond X, project A will give you a higher NPV. Now, the question that we may ask ourselves is, how the hell do we find this point, right? How the hell do we find this intersection point? Now, this is super duper easy to do. So what we're going to do is we're going to do what we call incremental cash flows. We're going to look at what is left from the difference in cash flows from project A and project B. This could sound like some black magic, but trust me, it actually does make sense. What we're trying to do right here, okay, is we're trying to assess the difference in cash flows, right? We're trying to assess, and I can even make it simpler to you, all right? If these two companies had the same cash flows, okay, would they have the same IRR? Yes or no? If these two companies had the same cash flows, 60K, 40K, 20K, 10K, 60K, 40K, 20K, 10K, would they have the same IRR? Yes or no? It's a quick question. If this was 60K and this was, 50K, would these two projects have the same IRR? If they had the same cash flows, they were identical, would they not have the same numbers? Yes or no? I need to see some yeses, I need to see some nos, I need to see you answer in the chat. Not sure, to be honest. Well, that's why I love doing examples. Like, if I copy this right here, and I put it right here, and just remove this. Let's do this. Okay. So right now, I could say that IRR, right? As you can see, and I'll put this as a percentage. Give me a sec. I'll do this. Oops. Okay. So we have the IRRs for both, right? They're right here highlighted. I guess we could even move it like this. So we have the IRR for both projects. All right. Now I'm telling you what would happen if they had the same cash flows. So obviously, the only difference between these two projects is this point and this point, right? These are the two only different points in terms of cash flows. Other than that, they're identical. Okay. Other than that, they're identical. Now, what I'm telling you is like, hey, if they had the same cash flows, all right, if they had the same cash flows, look at that. Would they not have the same IRRs? That's what I was asking you. If they have the same cash flows, if we plug them into our formula, we're going to get the same result. You know what I'm saying? If they have different cash flows, we're going to get different results. In this case, I'm asking you, hey, if they have the same cash flows, they would obviously have the same discount payback period, same profitability index, same NPV, same IRR, because they're literally identical. It's like Ditto and Pokemon, if you remember back in days. Okay. So with that said, what we want to figure out though is that obviously these two projects are not identical. That's exactly what we're facing, right? We know that these two projects are not identical. So what we could do is we could do a nice little trick. In French, we would say the passe-passe. We're going to do a little trick to be able to figure out, well, what is that specific, crossover rate? And we could actually do that by assessing their difference and kind of treating their difference as being a project in itself. Okay, so check this out. What we're going to do is we're going to calculate project A CF minus project B CF. Okay. Now, let me ask you a few questions. We're going to do A minus B for every single year of cash flows. Okay. So if we do minus 100,000 minus 100,000, what do we get? Do we get 0? Do we get 1,000,000? What do we get as a number? We get 0. What about 60,000 minus 60,000? What do we get? What do we get? Just quickly in the chat, takes 2 seconds. These are easy questions, easy answers. Okay, cool. 0. What about 40,000 minus 40,000? Obviously 0. Let me just make one correction. We're just going to set this number to what it's supposed to be. So 60 minus 30 obviously would be 30. I'm just setting the numbers back to what they're supposed to be. My bad. Okay. So 0, 0. So 20 minus 20 is equal to 0. And then finally, for year 4, 10K minus 50K is equal to what? 10K minus 50K. Just write in the chat super quick. Minus 40. Amazing. Good. So what we have here, and I'll highlight it, is what we call our incremental cash flows. Okay. These are our incremental cash flows. Highlight it in yellow. All right. Classic tail. These are our incremental cash flows. Okay. We're going to treat this difference between project A and this between project A and project B as being one little thing that we could try to find its own K. We could try to find its own IRR. Okay. So what we're going to do is we look at these two projects, we find a difference between these two projects, then we solve for its own IRR, and that's going to give us our crossover rate. All right, that's going to give us our crossover rate. So how we would do this is simply IRR. I could obviously do it on Excel, but I'm being a little loser. So IRR is going to be simply 30K over 1 plus K to the power of 1 plus minus 40,000, whoops, over 1 plus K to the power of 4. So this is how we're going to find the IRR of our incremental cash flows, of the difference between these two projects. Now I need somebody to tell me what would be our K in this case. What would be our IRR? Solve for X, solve for K. Tell me what that would be. It's gonna maybe take like a little bit of time, I guess.
Yeah. Sorry.
Yeah.
But like there has to be something on the left-hand side or the right-hand side to compute, no?
Oh, yeah, I guess. I'm sorry about that. This my head. Sorry, that was just on me. By the way, when you're solving for IRR, obviously this right here is always zero. Okay. This on the left-hand side is always zero. And I think that's an amazing like insight from Palantir. It's an amazing call. Is that once again, the IRR, okay, is the point at which this number here is equal to zero, where the present value is equal to zero, okay? So on the left-hand side, it's always zero. Sorry about that. That's on me. All right, so always remember that it's zero equal whatever cash flows we're trying to find over this K, okay? Very important, my bad. すみません、ごめんなさい。ごめんなさい。皆さんは、はい、日本人です。So I'll give you a little bit of time, just a poquito amount of time, and then I'll kind of just solve it. You're solving for X though. And I'll give you one trick. Actually, since we're here, let me give you a trick. I'll show you how to do it. I also have it in past recordings. If you do the homework, you will see it. But in the case that you don't want to do it, I'll share it right now. It's gonna be super useful. I'll put it here actually. I'll show you a way that you don't need to do it by hand. I know I'm a theoretical person, but for those who are doing it as we're speaking, you could watch this over the recording, but what you could do is you could actually go and press this thing right here. And it's going to show you CF0. In this case, you would do CF0 is equal to 0. You do enter. Then you're going to press the arrow down. It's going to show you CF1. Or I guess it's going to show you P1 or P0. No, it's going to show you CF1. Yeah. It's going to show you CF1. And you're going to make that, yeah, C01, my bad. And it's going to show you 30K. You're going to put that. Then you're going to go to P1. You're going to put it as 1. You're going to press enter every time. Then you're going to press your arrow down. You're going to have CO2. You're going to do that as being 0. You're going to do P2 as equal to 1. You're going to do arrow down. You're going to get to CO3. You're going to put 0. P3 is going to be equal to 1. Then you're going to get to CO4. Then you're going to put minus 40K. You're going to put P4 is equal to 1. Then what you're going to do, because you're OCD, you're just going to enter again, and you're just going to like go up your arrows and make sure that, you know, your CF0 is equal to 0, your CO1 is equal to 30K, and P1 is equal to blah, 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 just to verify your stuff. Once you've done that, you could click IRR. It's going to show you something right here. Then you're going to press compute, this thing here. Then you're going to press IRR, and it's going to give you an amount. That's how you do it if you want to use your calculator. If you look at the homework I gave you for today, like the study guide, you will see it in a video where I kind of like do it like this. But you could also use this formula right here. Okay, you could also use this formula right here. It takes 2 seconds. This is the logical way to do it. This is the, when you're such a logical pro. Did you use a calculator or did you use the like math? Which one did you use?
Calculator. I don't know, like for the capital budgeting, the calculator is like very weird to use. It's not like I'll try again.
Or you just press enter, but then maybe, you know, but you know how I do it. Just send me a video on Messenger, and I'll literally tell you, oh my bad, I think that's what you missed. And
Yeah, okay.
because you obviously know what to do. Like I know it. Lean got the correct answer. I'm gonna give you all a shot. Lean got the correct answer. Okay. If you guys want to see how we do it with math, it's pretty straightforward, but using your calculator is the easiest way. So yeah, what's up, Bishop?
Can you just repeat quick what to do after I input everything in the CF and the calculator?
Yeah, for sure. So once, did you make sure that they're all correct? So CF is
Yeah.
0, blah, blah, blah.
Yeah.
Once you've done that, just go into IRR. Press this button. Okay. Once you've done that, press compute and then press IRR again. Okay. should give you an amount. Yes. Yosh. Exactly. That's how we do it. And then obviously, if I just do this, IRR is equal to 10.06. So what does that mean? Okay, so I'm gonna do a quick rundown in like 30 seconds. Check this out. So you will press this thing right here. Right here, you're gonna see CO0. You're gonna press 0. You're gonna write 0. You're gonna do this, 0, enter. Once you've done that, you're gonna press arrow down. It's gonna bring you to CO1 type thing. You're gonna write 30, 0, 0, 0, 0 for 30K. Then you're gonna press that. You're gonna press enter, by the way. Always enter. You need to enter stuff you plug in. Then you're gonna do arrow down. It's gonna give you P1. You're gonna do 1. Enter, arrow down. CO2, you're gonna do 0. You do enter, you go down, P2 equals to 1. I think you kind of get the vibe at this point. Once you get to the 4, you're gonna do minus 40K. Enter, arrow down, P4 is equal to 1. Then enter, then you do the classic OCD game. You make sure that you wrote everything the right way. Once you've done that, okay, you're gonna press IRR. Once you've pressed IRR, you're gonna press compute IRR again, and it's gonna give you an amount right here. Hell yeah, that's what I'm talking about. Easy points on your exam, okay? So that said, it's equal to 10.06. Now, what does this mean for us? I think it should be clear. This means that our point right here is equal to 10.06%, okay? Our point right here is equal to 10.06%. The difference in these two cash flows will give you a specific point on the graph. Okay, that's very important. There you go. Okay, so that said, what I'd like to say is that in this case, our answer would be, yeah, what's up?
Sorry, so when you say the crossover point is the IRR of 10.06, does that mean that's the point where the two projects, both of their PVs at the same time equal their initial investment?
In this case, I think a really good way to look at it is the point at which both of their NPVs are equal to the same, okay?
Oh, okay, so they're equal to each other.
Yes, and I think this is a very good insight because notice once again that our vertical axis is the net present value, okay? And the net present value is a static point. This can only be one thing, all right? And the point at which they're intersecting is at 10.06%, and that's the point at which the NPV of project B and the NPV of project A would be equal to essentially the same. And if you really want, like I could kind of do it, I could show you an example. Give me a second, I'll be more than happy to. So you could really visualize it and just not kind of take my word for granted. But if we were to, put discount rate as 10.06, right, as being this amount, so we could call this IRR, right? So you would do this divided by 1 plus IRR power of this. Give me nothing. So this 2, 3, 4. You're gonna see what I'm doing. Just give me a second. Okay. Yeah, should make sense. Then you do some. So in this case, what I'd like to highlight is that this is our NPV, okay? This is our NPV. This is our discounted cash flows. You're gonna see what I mean in 2 seconds. Please. Okay. Just give me a sec, Georgia. You're gonna see what I mean. Boom. So notice, all right, that our IRR was 10.06%. And if we discount all of these cash flows, so if we discount 60K at that percentage of 10.06, we would get an NPV, so a net present value of this project of 9,347 for project A. But then if we do the same thing, so we also discount the cash flows of project B at 10.06, we will also get an NPV of 9.347. So to go back to our graph, this X, this crossover rate, this crossover point is literally the point at which the project A and the project B would have the same NPV. That's what I tried to kind of like showcase right here. I hope it's clear. So it's not like black magic. It's actually true. You know, it's actually true that this would be the crossover rate between the two. Okay. So that said, in our answer, we would say, if they ask us, when is project B more lucrative than project A? That is, over what range is the discount rate of project B higher than, over what range of discount rate, sorry, does project B have a higher NPV than project A? Well, we would say over the range of 0% to 10.06%, project B has a bigger NPV than project A. However, from 10.06% onwards, we would say that the NPV of project A is bigger than project B. And that's how you do it. That's how you would solve the answer. And in this case, you could say, when should they accept the project? It's a whole different topic, but you want to know, when is the project higher? When does it have a higher NPV? Well, here you go. This is a classic question on exams. I've seen it in final reviews. I've seen it in exams multiple times. And I feel like we did a pretty good walkthrough of what all these different things are. Yeah, what's up?
So if the projects are mutually exclusive, we pick the one that has higher IRR, right?
Yeah, 100%. You pick the one with a bigger IRR. Most cases, they're going to show you mutually exclusive projects with regular cash flows. And the rule of thumb would be to always choose a project with the higher IRR.
Okay.
Right. So I love IRR. I do a lot of work with that. I do real estate, and we do a lot of valuation of properties, and IRR is literally like the golden rule for real estate. So it's super fun. But this is a really important question to do. Now, I want to do one question that relates to WACC. I just want to make sure that everybody here kind of knows how to do it. These are easy points on the exam. So just give me a sec. I'll pull up a question on WACC. I'll kind of give you a quick perspective of what it's all about. What should you do? How should you go about it? It shouldn't be too hard. Just give me 2 seconds. All right. We're going to do a question on WACC super quicks. So I want to find one that's not too hard. Give me a second. Give me uno segundo, because there are ones that are a little bit harder than others. I guess we have no choice. We'll do a hard one. Okay, so let's do a quick question on WACC. I know that you guys all are busy, but okay, so let's do a question on WACC. Give me a second. I'm gonna try to populate it real quick. So I'm just getting the question right now, so I'm trying to find what page it's on. Okay, cool. Okay, so we're gonna go to page 70. Okay, we're gonna go to page 70. So this question is relating to this idea of WACC, okay? And I think that WACC is honestly a pretty straightforward concept to understand. And it relates, and I'll write it here. WACC is the weighted average cost of capital, okay? What does this mean in simple terms? The weighted average cost of capital is simply, literally, how much does it cost you to essentially deploy money or raise money, okay, to use money. So this is a very interesting idea, all right? So very interesting idea. And we're going to give ourselves a little like example. Let's say that we're a family, okay? We're a family and we have money, we have a lot of money, and we typically try to decide what we could do with our money, okay? We try to kind of think about it, try to see, you know, what are the things that could be done with our money. So let's say that the family money, the family fund, okay, we have, call it, I don't know, 500K. Okay, we have 500K. All right. And we have this epic project that could make us millionaires. Okay, we have this epic project that could make us millionaires. And this project, for example, could be, call it, I'll give you even better context. It's 2004. Okay. And we're literally, you know, we're at Fairview chilling, you know, family outing. And somebody comes to us and says, hey, guess what? And you're like, what? And they say the next big thing is Bitcoin. And all of us are like, what are you talking about, Bitcoin? Bitcoin, that sounds like black magic. But we're curious people, so we kind of think about it. So now it's at dinner at night, we're in our family council, and we're debating about this investment in Bitcoin. All right, we're debating about this investment in Bitcoin. And at the time, Bitcoin was super risky, and it still is, but like it was super, ultra, mega risky, all right, at the time. So I'm just trying to paint you a picture, all right? That said, don't forget that we only have $500,000, okay? So just think about that. That Bitcoin's a super, ultra, mega, very extreme project, okay? But although it's super extreme, the expected return we could make on Bitcoin could be, typically, it could be like, I don't know, call it, in this case, literally 400%. Or even more. Okay, so we expect Bitcoin to give us like 400%, but it's so risky. Okay, just think about it like that. And we can even be more pessimistic. We could say that's going to give us 45%. Anyways, painting you a picture, right? But we have a finance person in our family, and this finance person is telling us, well, 500K is all of our money. It's all of our savings for the family, and maybe we should consider our options. Okay. So can people tell me in the chat, what are different investments that we could make other than Bitcoin? Could we like maybe invest our money elsewhere? Could you give me a random place that, or like a few spots that you think we could go invest? Bashir said it best. We could invest in stocks. Well said. We could invest in stocks because 500K is a frick ton of money. It's a lot of money. So we should say maybe we could invest in stocks. And on stocks, how much percent could we expect on stocks per year? Can somebody tell me a random amount just for fun? How much could we expect on stocks per year? Yeah, let's go with 8%. So we can expect about 8% on stocks, okay? This is very important. We can expect to make 8% per year in the stock market. Okay? We could expect to make 8% per year in the stock market. So just to be like super annoying, we could expect to make in dollars, technically, we could expect to make $40,000 in the stock market if we invest at 8%. So now we're like, shoot, we could make 40K in the stock market if we invest in the stock market, if we invest all of our money. Okay, if we invest all of our money in the stock market, we could make $40,000. Is that clear to everybody? Yes or no? I think so. We're investing 8% because we're in the stock market. That's an alternative. It doesn't mean that we did it. It's just an alternative. We're just kind of talking together. We're having like a late night conversation with the family. You know, a little bit of wine. You know, a little bit of coffee. You know, a pizza. We're just talking together. Okay. So then let's say that Lean says, well, I don't know, man. Investing in the stock market, it's still kind of risky. Like, I mean, it's still kind of risky. Your money could go elsewhere. So you say, what if we take some money from the bank? We ask the money for we ask the bank for a loan, and we're going to use the loan to invest in Bitcoin or the stock market. Okay, is that something that we could do? Is that something that's like clear to everybody, that we could technically use somebody else's money to invest? Yeah, we could do that. We could ask for a loan. Essentially, we could get debt. We could ask for debt. We could ask for a loan. Okay, we could ask for a loan. We could ask for debt, and we could ask them. I don't know. We could ask them for 500K. Who knows? We could ask for 500K. Okay, but the person at the bank, he's not a fool. Okay, he understands that we're all very successful and blah 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 blah. But the bank still has to, charge us interest. So the bank's interest rate, okay, it could be, call it, I don't know. Somebody give me a random amount for the interest rate of the bank. 20%? I mean, it is a lot of money, but still 20%, that's a lot. We're gonna go with 2%. We're gonna go with 2.5, if anything. That's that's a lot of interest. But yeah, so 3%. So let's go with 2.5. So so our interest payment every year to the bank, technically, our interest payment to the bank every year on the money we essentially, took as a loan would be 12,500. Okay, 12,500. All right. Does that make sense to everybody that technically, if we take on such a big loan, that we would have to pay 12,500 a year in interest payments? Is that clear to everybody? Just quick, just as a perspective, just a quick set of yes or no's. Yeah? Yes or no? Like Georgia, Lean, Pamvir, is this clear? That if we took a 500K loan at 2.5% every single year, we would have this much as interest payments? Yeah, 100%. Okay, yes, cool. So these two amounts, okay, is what we call cost of equity and cost of debt. Okay, and let's put it in perspective. So putting in your money into something is something that's kind of stressful. We all think that when we have a lot of money that we're ready to do big things, ready to buy that new car, we're ready to buy a home, we're ready to take on more responsibilities and ready to invest. But we have an emotional tie to money. Money means something to us. I mean, it's literally correlated to the amount of hours we spend doing something, hopefully that we love. So there's a cost to using our own money. And that's why we like to look at different, investments opportunities. We like to look at the least risky investment, or at least investments that are not as risky. And that's exactly what we did in this scenario as a family. We had this great opportunity, Bitcoin, right? That could make us ultra rich. But we wanted to consider something that was more reasonable, something that we know for sure we could get, a return that we could understand and seek. That was the return in the stock market in this example, right? We used 8% as our benchmark. So the cost of us using our money, right, has to meet 8% at the very least, okay, for us to be comfortable with making a decision. Because for us, 8% was our benchmark, okay? That's the cost of our equity. The cost of our equity is about, in this scenario, it's $40,000. We have to beat $40,000 and by a lot, okay? That's the cost of our equity. If you want to have a visual figure, it would be $40,000, all right? That's if we want to use our own money. Is that clear to everybody? This idea of the cost of equity, this idea of opportunity cost, are we all understanding what I just said? Does it give you a more human idea of it? Yes or no? Okay, amazing. Now let me move on to the next point. Then we said, you know what, buck that. We're not going to use our own money. we're going to use the money of somebody else. It's a pretty good strategy. We're going to use debt. So we went to the bank and we said, hey, we want to use our 500K, but we're kind of scared to do so. So maybe we could use your 500K instead to invest in this idea that we have. And the bank said, yeah. They said, yeah, but at an interest rate of 2.5%. That 2.5% is how much we're going to have to pay to use somebody else's money. In this case, once again, it was 2.5%. And that meant that we had to pay $12,500 per year to take on this debt. That's how much money we had to pay to use somebody else's money. In other words, that's how much it would cost us to maybe use somebody else's money, to maybe use none of our equity, none of our cash. That's the idea of cost of equity, and that's the idea of cost of debt. Cost of equity is the minimum threshold of what we would need to surpass. It's very similar to the IRR. And the cost of debt is how much would we have to pay to not use our own equity, right? You could either use your money or you could either use somebody else's money. That's exactly what our example tried to showcase. We had our money here and we had a risky project to look at. So we had to compare what was our baseline to the risky project and what's our feeling towards that. Then we said, you know what, maybe we should just not use our money. Well, to not use our money, there's a specific cost to that. Okay. But at the end, there's only two alternatives. Either you use debt or you're going to use equity. In other words, cash. Okay. That's kind of like how we would split our pie together. Debt versus equity. All right. We could have that kind of duality there. All right. So that's the context that we would want to have in our mindset when we look at the cost of capital. All right. That said, I think we could all agree that using somebody else's money could be way better than using our money because we pay not a lot of interest and we get to maintain our money for sure. And we get to benefit from the upside of our investments. It's pretty cool to use debt. It's a pretty cool tool if you know how to use it properly. So that said, I gave you context, I hope, at least on this idea of what the heck, this idea of cost of equity, this idea of cost of debt is all about. So now we have this question. This will be our last question that tells us, consider the following information to calculate a firm's WACC. So to calculate a firm's weighted average cost of capital, how much is their opportunity cost on projects? Okay. So they say that the company at hand has a debt to equity ratio of 1.2. They say that their before tax cost of debt is 7%. So that's how much interest rate they need to pay. They say that the risk-free rate is 3%. They say that the beta is 1.2. And they say that the market return is 8%. And they say that the tax rate for this company is 40%. Before we proceed, I'd like to kind of just, maybe show you what the formula is for WACC if you don't know already. It's very straightforward. It's not very complicated. It's super simple. So just let me pop it off real quick. Yeah, I guess we can go with this, like this better. So this would be our formula for the weighted average cost of capital, okay? Where we have equity and we have the value of equity plus debt. So equity, we have RE, which is a cost of equity. This could have a bunch of different symbols, by the way. You just want to understand the idea behind it. Okay. And then you could also have, for example, you could also have the cost of debt, which would be RD. And you would also have D over V. All right, so debt over the value that is being invested. All right. Now, just a few things to say. Did anybody here not see the formula for WACC? Is it the first time that you see WACC? It doesn't have to be this one, but have you ever seen the formula for WACC in class? Okay. What about the others? Have you ever seen the formula for WACC? Okay, no, okay, well, that's not a problem. So yeah, the formula for WACC, essentially, what it says is like, from the entire set of money that you have, how much was deployed to equity? How much was deployed to debt? So just for you to kind of internalize that, once again, if we decided to take on debt, let's say that we decided to take on debt, okay? We said, you know what? We like the investment, but we'd still like to use somebody else's money. So let's say we went to the bank and we took their 500K. How much total cash do we have on hand right now? How much total cash do we have in a bag somewhere in our basement? How much cash total? We had 500K and we went to the bank and we asked them for another 500K. How much total cash do we have right now? How much? Somebody tell me. How much total cash do I have in my pockets right now? Like as soon as they give me the money. How much? I only got one answer in the chat. It's concerning. How much total cash do I have? Should take 2 seconds to write it in your keyboard. Exactly. So no, the answer is 1 million. 1 million, because you had 500K at the beginning. You went to the bank and you asked them for 500K. So you would just do this plus this, and you would get $1 million, right? If I go to the bank and I say, hey, I already have $500,000, but I want you to give me $500,000. They give it to you. Now you have 2 bags of money. You add those 2 bags of money together and you have $1 million. Is that clear to everybody? Is that super duper clear? Does that make sense? Are we seeing that right now? Hell yeah. Okay. So we have $1 million right now. So if you'd want to look at, for example, if you'd want to look at, I guess I can just do this. If you would look at the proportion of debt to equity that we have right now, right? Our pockets right now would look something like, having like a stroke, would look something like this, right? Our debt to equity ratio would look something like this. Because we have 50%, you know, that's given to this idea. I guess I could format it better. Better for you guys, you can see it. Okay, so as you can see, we have 50% of our money that is now equity, or call it from our family fund, right? 50% that is equity from a family fund, and 50% that is from debt that we took from the bank, right? I hope that's clear. But let's say that we took, call it $100,000 from the bank. How much total money do we have? If we had 500K and we took $100,000 from the bank, how much money do we have now total? How much? We had 500K and we went to the bank and we said, you know what? I only need $100,000. How much total money do we have? Total money. Yeah. We took 100K, but we had 500K at the beginning. That's what we had in our pockets. Bashir says 600K. What about Georgia, Lean, and Paramvir? How much total do we have? What do y'all think? Is it more? I think it's more. Is it more? I don't know. There you go. Exactly. We would have essentially, whoops. You would have 100K. That is going to be essentially, we would have 100K that's in the bank, right? That's in a loan. We would have 500, which would never change in this case. So as you can see, our ratio, it could be so many different things depending on how much debt we took. All right, so that's important. That's what I'm trying to tell you. Essentially, your DV in this formula, right? It tries to show you, in this case, how much percent of your entire money. Yeah. Essentially, it will always be given, but it could be given in a nuance, which is exactly what this question did, okay? It gave you a nuance, and you'll see how we express this nuance. So check this out. In this case, our DV is 37%, and our EV is, 63%, okay? 63%, all right? Is that clear to everybody that our debt over value is 37% and our equity over value is 63% according to my example? Is that clear to everybody? Yes or no? According to this example right here. Okay, perfect. All right, so that's our different values. However, in a question, they could give you what we call is a debt to equity ratio. How much debt do you have, right? Vis-a-vis the equity that you have. So in this question, we could actually solve for that. We could have given you instead, we could have said, hey, your debt to equity is equal to 60%, or I could have said 60%, like 0.6, okay? I could have said that this is your debt to equity. I could have said that your debt to equity is 0.60, and you didn't know the percentages yet, okay? What do you do in that instance? How do you figure what your EV and what your DV is? That's something that our question right now is asking us to do right here, right? They're giving us your debt to equity ratio, but they're not giving you your E over V or your D over V. So how do we solve for our E over V and our D over V? It's a very, very simple trick, okay? And before we look for that trick, let me just give you a little bit of context. Does everybody know what is 63 plus 37? What is 63% plus 37%? Can somebody tell me? What does that give us? I need everybody to write it in the chat. What does that give us? It gives us 100%, right? It gives us 100%. That's a very important, very, 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 very important realization to have. Because regardless of what's the relationship between the two, it will always be equal to 100%. Regardless of whatever relationship I do, we will always have 100% as the sum of, the proportions. I feel like that's something that is extremely clear to everybody. No matter what, we're going to have a proportion that's going to give you a 100%. Okay, 100%. That's super important. Don't forget that. So now that we know this, and in this scenario, the question is telling you, we're going to work with this as an example. They're telling you, hey, your DE, your debt to equity, is equal to 0.5. It's equal to that. So how do we solve to find our DV? How do we solve to find our EV? That's a very, very important question. So with that said, we do know something, okay? We do know one little thing in this question. One thing that we definitely do know is that we know that, once again, debt over the value, so debt over V plus E over V will give us a specific amount. What would this give us? What does this give us right here? D over V plus E over V. It gives us 100. Hell yeah. Right? What does it give us? Exactly 100. It gives us 100 or simply 1. 1 or 100%. They're both the same thing. So that's super important. Okay? That's something that we do 100% know. All right? So with that being known, what we also know is that DE, right, is equal to 0.5 in this question. Okay? But by that same token, we could also say that D could simply be equal to 0.5 times E. Does that make sense? That D over E is equal to 0.5, and because of that, we could also say that D is equal to 0.5 times E. Is that some quick maths that we could all see and understand and internalize? Yes or no? Do we see how, do we see the natural progression? What I did is I just brought this to the other side. Yes or no? I see one yes, I need to see, oh yeah. I'm just using this in this example right here. Because we did debt over equity, okay? I'm not using this example just yet. All right, so that said, do we understand this part? Georgia and Lean, do we see this? Hell yeah, okay, cool. So now we know that D is equal to 0.5 E. What I could do now, I could do something pretty cool. I could actually substitute this right here for what we have right here. So our formula that was D over V plus E over V equals 1, we can now say that 0.5 E over V plus E over V gives us 1. So far, is everybody on the same page? Do we see that? Does this make sense? Are we okay with that? That we could substitute? Amazing. Okay, cool. So we want another color. So because of that, we could technically say, right? Because of that, we could technically say that we could simply just do just the sum of the two. Let me just make sure that I'm not cracked out of my mind. It should be fine. Yeah, it should be fine. Technically, because of this, we could just simply say that we have 1.5 E over V. I feel like that's something that we could do. I'm going to kind of wing it like that. And that should be equal to 1, if I'm not mistaken. Let me just see if I'm being stupid. Give me a sec just to use my brain for 2 seconds. So just give me a sec to use my brain. Don't want to make a mistake. I don't know why I'm having trouble to use my brain right now. Just try something. Wow, my calculator broke. It's crazy. Yeah. Just I'm trying to think about a trick. Sorry about that. Yeah, okay, cool. Sorry. Yeah, so you could definitely do what I just said. I was just trying to think about something. So you could simply do 1.5 E over V should give you 1. Okay, should be equal to 1. So by definition, what you could do is you could simply do the following. You could say that EV is equal to, I don't know why I bugged so much. I really don't know why. You could simply do 1 over 1/5, right? Because you're going to divide this number on this side, and it's going to give you EV is equal to 1 over 1/5, and that should give you something along the line. I don't know why my calculator is not working. So we do 1 divided by 1/5. Should be this one here. And it should give us the same amount that we have right there. Exactly. Clearly, my brain is way too tired because that was so easy, yet I don't know why I bugged. So yeah, 2 things to say. This gives us our equity, right? That we have right here, which is great. But this also means that by definition, our DV would simply be equal to 1 minus EV. In other words, it would be equal to 1 minus 0.67. DV would be equal to 0.33. So that said, I think we know how to solve for our debt to equity ratio and turn that into our, essentially, our debt over value and our equity over value. So that's how you do it. Now, with that said, I feel like we have enough information to be able to solve this specific problem. All right. that said, let's give it a shot. And we'll do it quick. So in this question, they tell us, hey man, we want to find the firm's WACC. So in a question like this, when you get something similar to this right here, you want to remember, okay, that's probably the first thing you want to solve for. So in this case, we're telling you that debt to equity is equal to 1.2. Now let me ask y'all, if debt to equity is equal to 1.2, how would we simplify this formula? How would we simplify this formula? Can somebody tell me how would we simplify this formula? In the chat. What did we do last time? What did we do last time? What was the first thing we did once we had something like this? What was the first thing we did when we had something like this? Exactly. Hell yeah. There you go. So we would have D, right, is equal to 1.2 E. Then the next step, right, would be the following. We know that D over E plus E over V is equal to 1. I'm clearly tired. That's crazy. So then we would just change this into being 1.2 E over V plus E over V. And that's going to be equal to 1. Now, what's interesting is that this leads us to having what? How could we simplify this further? How could we simplify this further? What would I put at the top here? What would we have here? The top right here. What would we have here? There you go. Hell yeah. We have 2.2 E is equal to V, such that EV is equal to 1 over 2.2, such that E over V is equal to how much? Somebody tell me in the chat. Somebody tell me in the chat. What would that be equal to? What would that be equal to? There you go. Yeah, it'd be equal to 0.4545. Okay, that would be our number. And so by definition, what would be DV? Could somebody tell me, somebody other than Paramver, what would be our DV? What would be our DV? Thank you, Georgia. Thank you so much. This would be our DV. Okay, this amount right there. So now that we have that, we could then clearly plug that into our formula. However, in this formula, they didn't give us our K. They didn't give us our cost of equity. How would we find our cost of equity in this question? How would we find our cost of equity in this question? What would we do with the information provided? What would we do with the information provided? How would we solve for K? No clue. I mean, this should be pretty straightforward. Read the question. Let's read the question together. They're giving us the risk-free rate. They're giving us beta. They're giving us the market return, and they're giving us pretty much giving us a lot of classical information. Where do we see these topics usually? We see them in CAPM. Nowhere else. You never see beta anywhere else, especially not with the risk-free rate and the market return. So for that reason, we know that we need to use our CAPM formula. So K is equal to the risk-free rate plus beta ERM minus RF. So can somebody tell me, what is our K? What is our K? Somebody other than Palmvert, what is our K? Somebody other than Palmvert, what is our K? What is our K? The chef says 9. That's possible. I don't know yet. I need Georgia and Lean to give it a shot. What is our K? There you go. Amazing. Perfect. So our K is going to be 9%. Right? Now we have enough information to plug this in within our formula. So remember, WACC, the weighted average cost of capital, is equal to 2 sections. All right? I'm going to write the first section, I guess, in different colors. Give me a sec. So now we have enough information for our formula. So we could go ahead and build it up. So the first section would be essentially related to our cost of equity. So we would only do EV times K. That's honestly all that you need to do. It's as easy as that. There's nothing else that you need to do. That's the first section. You're going to add that to another section, the one related to debt. So it's going to be DV times KD, or the cost of debt, times 1 minus the tax rate. Okay. Now, the reason why we do this, if you remember from our classes on 217 back in the days, there's this idea of the depreciation expense. There's this idea of the interest expense. There's this idea of amortization expense. And expenses, essentially what they do is they allow you to pay less taxes. And that savings that you do in paying less taxes, technically is more cash in your pocket. So what we're trying to do here is we're trying to look at that saving, okay? And we're trying to plug it in. Anyways, that's just for you to have a context. So that said, let's begin. So in this question, what was our EV again? Do you guys remember? What was our EV again? If you remember, it's written on the screen. Yeah, so we would do 0.45 times, what is our KE? What is our KE? Can somebody tell me, what is our KE? What is our cost of equity? Times 0.09. Perfect. Then we would have to do for, what is our DV? Can somebody tell me what's our DV? What's our DV? What is our DV? We had it before. If our EV is this, what is our DV? Nice. Now, what is our cost of debt? 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 What is written in our question that we didn't use yet? Hell yeah, there you go. And then we'd have 1 minus what? 1 minus what? Hell yeah, 1 minus 0.4. So with that said, can somebody tell me what is our WACC? What is the answer for our WACC? What is the answer for our WACC? Okay, I see 2 answers. I'm missing 2 more answers. I'm missing one, like, yeah. So the answer would be 6.3816-ish or within that realm. But what I'd like to say is very important is that because we rounded our answers, so for EV, we just put 0.45 and for DV, we just put 0.54. That's why Bashir and Lean, they get 6.31, and that's why Georgia got 6.3816. The idea is that obviously on an exam, you do not want to round, your answers off throughout the process, and Georgia would have the most like close answer. But for what we just did now, what Lean and Bashir had was correct. Okay, so that's how you solve for WACC. Now, that said, what I'd like to say, that's kind of like the picture for WACC. We kind of had a little bit of an idea of what we did for the cost of capital. But what I would like to do from now on is just kind of highlight something on screen. So this is what we just did. We did this right now, okay? We did this right now. We did our tutorial and we did our deliverable. What I need you to do, and I know it's late and I know you're tired, but you still get like maybe 10 or 20 minutes to go eat, relax. I would need you to immediately go read your capital budgeting slides. There are 2 sets of slides with questions. You don't need to do them, but I would go through that immediately. Once you've done that, okay, once you've read all those nice things, I would then move on to doing this. Okay, so as soon as you can cross this one out, I would start doing some final practice problems. Do at least 5 that cover capital budgeting and WACC. That's the minimum. 5 is the minimum. It should not take you more than like 30 minutes to do 5. This took you 30 minutes and this took you 30 minutes. Okay. Once you've done that, you could start with any of these 3 buckets. I would probably recommend starting with the recording of, the previous crash course for the final mock exam because you get a lot of really good exposure. Then after that, I would suggest doing the notes. And after that, I would suggest doing the YouTube video in that order. This would be what I would do if I were you. I would put in the reps right now. I would do that. It should not take you more than maybe 2 hours, 2 hours and a half after this. But you're not like stressed. You're doing this because it's for your grade. You're doing this because it's for your success. That's how I would do it. Go get some food. Go maybe to the library. Do it with a friend around, but just get your exposure to these questions and do it in the process that I just said. If you do that, you're doing the right steps. Okay? That's what I would recommend. And then tomorrow, you'd have another set of things to do. What's up, Paramvir?
Yeah, so we have a formula, like we use the CAPM formula to calculate the cost of the K equity, the cost of equity, right? But is there any formula to calculate that, what is it called? The KD?
There would only be one, but that would be essentially finding your yield to maturity in a bond question. Okay? But that's like the most extreme and rare of questions. But nonetheless, you do have the solutions in my Google Drive. I would not optimize for that. But if you were to do that, you would just have to solve. You'd have to use the bond valuation formula. Okay. And then you just have to find KB. Simple as that.
Oh, okay. Got it. Oh yeah, makes sense.
That you've never seen before. Okay.
So in terms of cost of capital, like this is pretty much all we got, right? Like WACC and computing WACC, that's it.
Yeah. Cost of capital.
And it's pretty much standard, like in all questions.
Yeah, sometimes they may give you a freebie and not ask you to change your debt to equity, blah, blah. But what's cool is that you have one question here. You have this theoretical question. You have this one that relates, as I said before, to whatchamacallit, to this idea of then you have this other question on computing the equity. Then you also have a question in so as you can see, where is it? If you look at this one right here, if you look at this video, okay, the reason why I'm pulling you guys towards that is because we do like 1 or 2 questions on it from the mock exam of the past. But if you don't do it on like today, you'd also be able to get exposure to it on Monday next week or Tuesday next week if you follow the homework, because there's like 3 questions on WACC in both homeworks. Okay, so you do get a lot of exposure to a different set of questions. And then if you look at the week, as you can see here, week 10, session 10, week 11, session 12, type of week 11 and week 12, you're going to see a few additional questions on WACC that you could kind of walk through. So here is I'm trying to spread out your exposure to a bunch of different questions. All right. And like that, you kind of just get in to put in the reps. If you do this, I think you're chilling. Okay.
Thank you.
So I'm gonna be an asshole. I'm gonna text every single one of y'all every day. I'm gonna do it tonight as well to ask you like, hey, how's the studying going? But also like, did you do the homework? You know, which ones did you do? And kind of just keeping you accountable. Ideally, you do at least, excluding the tutorial and the deliverable within the tutorial, you should do at least 2 or 3 every day. If you do that, I think that you're doing much more than any other student. So you for sure will be above the average. If you really work hard and you try to understand, you will for sure surprise yourself. And if you do everything, I mean, I think you're getting an 80 plus. Okay. By the way, before you guys go, I'm gonna just, you know, be a little bit annoying, and I'm gonna show you something. And I want you to tell me if it's cool or if it's not cool. Okay. So what I'm trying to do for next semester, or for like, yeah, for September, for all the other classes that you may take. So what I did here, all right, is I created like this random question, okay, which says that if you know a security has a beta of 0.18 and the risk-free rate is 3% and the return on the market portfolio is 3.3, what would be the required rate of return on the security? In other words, we're doing a CAPM question. But what's really cool is that you could also, as you can see, get the answer from it. We could also randomize the question to have a bunch of different questions that you could do. So you could randomize it to have exposure and kind of repeat questions again and again and again. And then if you want to, if you're not sure about how they did it, you could also click to show solutions, and it would show you the solutions in every scenario based on the formula. So what do y'all think about this? Is that cool or is it not cool? Would you use that or would you not use that? If you like, obviously it's going to be for more than just this specific question, but this is just like a little like test. Yeah, so I would do that for every single question. So like even for a question tonight, it would be like you would see the step-by-step solutions, and you would be able to kind of like, you know, click to randomize and have exposure to a bunch of different ones. Would you guys actually use that? I'm gonna do it for your future classes as well. Yeah, obviously, like if you're in finance, this will be done for FINA 210, FINA 385, FINA 395, and then you guys already took Comp 17, but that as well, and Comp 305 in this one as well. So yeah, okay, cool. Just wanted to see what y'all think. I think it's pretty fun. It's not bad. Okay. All right, well, that was my shameless little try to get some feedback. On that end, I need you guys to do the homework. I really want you guys to do the, because I want you guys to do well. And then, yeah, we're going to see each other on Friday, 6 to 8. And we're going to just do a little recall together on a few questions and kind of just work it out. Okay? So on that note, hope this was helpful. Recordings will be posted right after. And with the homework, you're allowed to ask me questions, so please do. And like that, we could work through it together and maximize. All right? My pleasure. I know you guys will do amazing. Please follow this and you will do even better. All right? Okay. My pleasure, my pleasure. Toodaloo.
Bye.